Imagine you are lying on your back under a dark, quiet sky. The air is still, your heartbeat slows. Above you, the stars look like tiny watchfires scattered across a vast plain. You feel small and, somehow, included, like the night is a room, and you are invited to rest inside it. Then a curious thought arrives. What is on the other side of that room? How far does this night really go? Tonight we will travel to the edge of what we can know, and then lean gently past it. We will not rush, we will breathe, listen, and let the universe tell its story in simple words. This is not a sprint through equations. This is a quiet walk to the horizon. First, a soft truth. We cannot see all of the universe, not because it ends in a wall, or because our telescopes are weak, but because light takes time to travel. The glow from a distant galaxy is a message in a bottle drifting toward us across an ocean of darkness. If the bottle has not had enough time to arrive, we cannot read it. That is the observable universe, the part whose light has reached us since the beginning of time as we know it. Now another gentle truth. While the light is on its way, the ocean itself is stretching. Space is not a stage with fixed boards. It is more like a slowly inflating fabric. Imagine dots drawn on a balloon. As the balloon swells, every dot sees every other dot drift away. No dot sits at the center. The center is in the air that fills the whole thing. Even if you could sprint faster than any rocket, you cannot outrun the fabric beneath your feet. The more distant a galaxy is, the more the stretch carries it. Put these two truths together, the travel time of light and the steady stretch of space, and you get a kind of horizon. Not a hard edge, just a limit to what can send us a message so far. Beyond that horizon, there may be countless more galaxies. We simply have not had time to meet them. Does that mean the universe stops there? Picture a calm sea at dawn. Fog hides the far shore. If there is one, you would not say the world ends where the mist begins. You would say, that is as far as I can see. The cosmic horizon is like that. It is a curtain made of time. So what lies past the curtain? There are several possibilities. One is that the universe goes on without end. No walls, no edge, just more of the same pattern of galaxies and the dark spaces between them. Another is that space is finite but unbounded. That sounds tricky, but you already know it. Walk north long enough on Earth, and you circle back without ever stepping off an edge. A space like that has no outside. It is complete and curved, yet endless to explore. There is also a playful idea. The universe might be multiply connected. Think of a hall of mirrors, where walking straight can bring you back to where you started, but from a new direction. In a cosmos like this, light could take a long, looping route and show us repeated patterns in the sky, like a subtle echo. If those echoes exist, they are faint, and the night keeps its secret well. Still, the other side might be another path back to here. You may wonder about the beginning, the hot, bright youth of everything. We still feel its afterglow as a thin bath of ancient light spread across the sky. It is smooth and quiet, like the cooled memory of a fire that once warmed all space. That glow is our oldest photograph, our baby picture as a universe. It tells us that whatever the whole looks like beyond our horizon, the part we can see grew from a simple, even state and has been stretching ever since. But there is a twist. The stretching is not slowing down. It is gently speeding up, as if some hidden pressure is pushing space apart. We call this dark energy, not because it is spooky, but because we do not yet know its true face. For our journey tonight, the effect is enough. The horizon changes with time. Some faraway places we can see today may drift beyond message range tomorrow. More of the ocean slips into the mist. And still, the mind asks, what is beyond? Truth is patient. It allows more than one answer to rest side by side while we learn. Perhaps the universe is infinite. Perhaps it is finite but wraps around. Perhaps our visible bubble is only one patch in a much larger quilt, a quiet chamber in a palace of many rooms. If there are other rooms, They may hum with different notes, hold different laws, carry different kinds of stars, or they may be just like ours, repeating without end. We do not know yet. For tonight, let the not knowing be a comfort. Let it be the soft pillow beneath your thoughts. You are part of a story that is still being told. A listener at the edge of a vast sea. The horizon is not a prison. It is an invitation to imagine, to explore, to keep asking gentle questions as you fall asleep. And as you drift, remember the dark is not empty. It is full of time, full of light on its way, full of places we have yet to meet. On the other side of the universe, there is not a wall, but a promise. Where our sight ends, wonder begins. Breathe in, breathe out. The night is wide, and you are safe within it. In the next part, we will follow a single beam of ancient light across the swelling sea of space, and watch how horizons move, how messages fade, and how the cosmos keeps its quiet rhythm. Close your eyes and picture a single photon, one tiny particle of light, born in the very first fires of the universe. It has been traveling for nearly 14 billion years, crossing an ocean of time, carrying a story of where and when it began. This photon has never stopped. It slipped past galaxies forming, past stars igniting, past whole clusters drifting apart. And at last, it lands softly in the lens of a telescope, or even on your eye, whispering, "I am from the beginning." This is the kind of messenger that tells us how vast the universe island. Each one is like a postcard from the edge of sight. But here's the mystery. No matter how long we wait, no matter how sensitive our instruments become, we cannot collect postcards from beyond a certain distance. That is not because nothing is there. It is because time itself is too young for the light to have reached us. Imagine sending a text to someone across the world, but you have only just pressed send. The message is real, but it has not arrived yet. That is the situation with galaxies beyond our cosmic horizon. Their light is still on its way. Now, think of the horizon not as a line, but as a bubble around us. Every observer in the universe has their own bubble, centered on them, defined by the age of the cosmos and the speed of light. If you could ride with a galaxy 10 billion light-years away, it too would see a bubble, with us at the far edge of its reach. In this way, the horizon is personal, but universal. Each place is the center of its own observable universe. That can feel strange, but it is true. And here is another gentle puzzle. The universe is expanding faster and faster. It means that some galaxies we see today are slipping away, carried outward on the stretching fabric of space, until their messages will never reach us again. They are not moving through space like a rocket. It is space itself that is widening, like dough rising with raisins inside. If you draw little dots on the dough, each one drifts farther from the others as the whole loaf swells. The dots are not racing away on their own. They are simply passengers in the rising. That is what galaxies are, passengers in the cosmic expansion. But this expansion creates a future horizon. Even if we waited forever, there will be regions of the universe we will never hear from, because the space between us grows faster than light can cross it. Imagine chasing a boat down a river, while the river itself is widening into a lake. No matter how fast you swim, the distance grows too quickly. That is what dark energy is doing to the fabric of space. It is turning rivers into lakes, lakes into oceans. So what lies beyond that unreachable edge? The answer could be more of the same. More galaxies like ours, more clusters of stars, more swirls of dust and gas. But there are other ideas. Some scientists suggest that beyond our horizon, there might be regions of the universe with slightly different properties, places where galaxies form sooner or where the cosmic fabric bends in different ways. These are not proven facts, but possibilities born from the equations that describe how space evolves. It may also be that our universe is not alone. Some theories describe an endless foam of bubble universes, each with its own laws and histories. Our observable universe would then be just one bubble in a vast cosmic sea. Others imagine the universe curling back on itself, so that beyond is simply another path leading home. In either case, the horizon is not the end. It is a veil. Now picture yourself standing on a quiet shore, looking at an endless sea. The water stretches so far that your eyes cannot tell where it ends. Does the sea stop just because you cannot see the far coast? No. The unseen is part of the whole. The universe is like that. Our horizon is only a limit of sight, not a limit of being. And here is the soothing part. You do not need to solve every mystery tonight. You do not need to know whether the cosmos is infinite or finite, flat or curved, alone or one among many. What matters is the wonder of asking the question, of gazing upward and feeling the horizon pull at your imagination. The unknown is not an enemy. It is a friend, offering endless stories, endless dreams. As you breathe, let this thought settle. The universe beyond our reach is not empty. It is alive, with light still traveling, with galaxies still blooming, with history still unfolding. Somewhere, a photon has just set out, and billions of years from now, it may brush across the eye of a distant being who wonders about you. The horizon is not a wall. It is a promise. In the next part, we will follow the ideas of infinite space, what it means if the universe never ends, and how that shapes the way we see ourselves inside it. Imagine space as a hallway with no end. You take a step, then another, and the floor keeps appearing beneath your feet. The walls never meet, the ceiling never tilts down. That is one way to picture an infinite universe. Wherever you go, there is more. No center, no edge, only distance unfolding. If space is truly infinite, a gentle calm follows. There is room for everything the laws of nature allow. Every kind of star, every kind of galaxy, every quiet world where frost paints the dawn, and every hot blue sun that burns bright and fast. In infinity, rarity does not mean absence. Even the uncommon has a place to exist. But if space goes on forever, why isn't the night sky blazing with light in every direction? The answer is soft and human-sized. The universe has not been shining forever, and light needs time to arrive. Distant places are young in our view, still sending their first letters, and as space stretches, ancient light stretches with it, losing energy and fading to a cool glow. The night is dark not because space is empty, but because its messages are dimmed and delayed. Even in an infinite cosmos, patterns appear. Galaxies gather in long filaments, like dew beaded on a spider's web. Between the strands lie great, quiet voids. Up close, things are lumpy and lively. Far away, the lumps average out, and the view becomes smooth, like foam seen from high above. This combination structure nearby, smoothness at a distance, matches what we see. How do we tell whether space is infinite or merely very large? We look at its shape. There are three gentle options. Space can be positively curved, like the surface of a sphere. It can be negatively curved, like a saddle, or it can be flat, like a calm, endless sheet of water. The oldest light in the sky, the afterglow of the Big Bang, carries patterns that work like a ruler laid across space. When astronomers measure those patterns, they find a very flat, very wide universe. If there is any overall curvature, it is too slight for us to notice so far. Flatness does not prove infinity, but it opens the door. A nearly flat cosmos could still be finite if it wraps around in clever ways, like a video game map that loops at the edges. Yet the simplest reading of the sky is this: space is vast beyond our sight, and it may have no end. Infinity also brings playful consequences. If there is truly no limit, then somewhere far beyond any chance of contact, there may be regions that look almost like our own. Same kinds of stars, same sorts of galaxies, even similar histories told with different details. Go farther still, and arrangements of matter could repeat, the way long strings of digits eventually show familiar patterns. That does not mean there are meaningful copies of you. It simply shows how generous infinite space can be with possibilities. Think of a library without walls. Shelves stretch into the distance, and each book is a small, self-contained sky. Nearby you find stories like the ones you know. Farther out, stranger tales appear. Keep walking, and you will never run out of pages to turn. That is the feeling of an infinite universe, not crowded, but generous. And yet, infinity is not required for wonder. Even a finite cosmos could be far larger than our observable bubble, so large that no ship, no signal, no lifetime would ever tour it whole. In practice, both infinite and merely immense feel the same to us. We explore what our light allows. We dream about the rest. Edges raise another question. An edge suggests an outside, and an outside suggests a place beyond space. But space is not a room inside a bigger house. It is the house itself, the geometry that contains all locations. If space is finite, it can still have no edge, just as Earth's surface has no edge. You can travel forever and never fall off. If space is infinite, it needs no outside at all. It's simply island. Sometimes people imagine racing faster than light to beat the horizon and see the whole. For tonight, let that thought go. The speed of light is not a traffic sign. It is woven into the way space and time fit together. It is part of the fabric. Instead of trying to outrun the weave, rest on it. Let it carry you. So, what does the other side mean in an infinite universe? It means there is no opposite shore, no final wall to touch. The other side is always farther on, more of the same grand pattern. Stars born from gas, stars dying into dust, dust becoming new stars and worlds. The rhythm repeats, not in circles we can map, but in themes we recognize wherever we look. If this feels too big to hold, bring it back to your breath. Inhale and picture a galaxy filling your chest, spiral arms, glowing clusters, a calm, bright center. Exhale and let the galaxy drift into the background of countless others. You are not lost in this scale. You are connected to it. The atoms in your body were forged in stars. Your heartbeat keeps cosmic time, slow and steady, patient as the dark. Before sleep takes you, remember this. Whether the universe is infinite or only immeasurably vast, our part of it is full of meaning. A single shard of starlight can tell a story older than any mountain. A small patch of sky can teach us the rules that guide the whole, and your quiet attention tonight is part of that story, the way the universe becomes aware of itself, one resting mind at a time. In the next part, we will explore a finite but unbounded cosmos, how traveling straight can bring you home without ever turning around, and how astronomers search the sky for the subtle echoes such a shape would leave. Picture yourself setting off on a straight path through the universe. No turning, no detours, just one endless line. In everyday life, a straight path eventually leads you far away. But in a finite, unbounded cosmos, that same path could bring you right back to where you started. Not because you turned, but because space itself bends and loops around. This is hard to imagine, so let's use something familiar. Think about Earth. Walk north. Keep walking, and you'll eventually arrive back where you began. The Earth's surface is finite, but it has no edge. There's no wall at the end of the Arctic. Space could work in a similar way, curved, not in 2 dimensions like a globe, but in 3 dimensions or more. Now, imagine the universe as a giant balloon. The surface of the balloon has no edge, but it is still limited in size. If our cosmos is like that, finite but unbounded, then traveling far enough in a straight line might loop you back from behind. The universe could be self-wrapping, like the ultimate cosmic racetrack. If this were true, light itself could make the journey. A beam might circle space and return to its starting point, carrying an echo of its original message. That would mean we could, in theory, see multiple images of the same galaxy in different directions, as if the sky were a hall of mirrors. Scientists have searched for this cosmic echo in the oldest light of all the cosmic microwave background, the faint afterglow of the Big Bang. This afterglow is patterned with tiny hot and cold spots, like freckles sprinkled across the sky. If the universe wrapped around, those freckles might repeat in a special way, revealing the shape of space. So far, we haven't found repeating patterns strong enough to prove it, but the possibility remains. Space may be finite, gently curved, and folded into itself. What would it feel like to live inside such a space? At our scale, no different at all. You could never walk far enough to test the loop. Even light may take longer than the current age of the universe to complete its circuit. To us, the cosmos would still look endless, but in truth, it would be a grand illusion, a stage with no curtains but a hidden design. A finite cosmos also raises a comforting thought. If the universe loops, then everything is connected in a seamless whole. There is no outside, no place beyond space. Every path is contained within the same vast shape. It gives a sense of completeness, of being inside something that is whole and sufficient. And yet, the universe is not static. It expands. If space is finite and expanding, it is like a balloon being inflated, not because galaxies are rushing outward through emptiness, but because the very surface of the balloon is stretching. The shape grows, but it still has no edge. That is why distant galaxies recede from us even though we are not at a center. On the balloon, every point sees all other points moving away as the surface swells. For sleep, let this be a gentle vision. You are resting on a curved surface too large to see. Around you, countless stars drift apart, carried by the swelling fabric. Far in the distance, echoes may be circling, messages on roundabout paths. You do not need to chase them. They are already part of your sky, woven into the tapestry of light you see tonight. The mind loves to ask, what's beyond? But in a finite, unbounded universe, there is no beyond. The question itself fades like a ripple on calm water. You cannot leave space, because space is not in something else, it is everything. Just as fish cannot swim beyond the ocean's water, we cannot move beyond space. It is the stage, the sea, the fabric. And here lies a quiet comfort. Whether infinite or finite, the universe always holds you. You are not outside, you are not separate, you are part of its shape, part of its unfolding story. The atoms in your hands have curved with the cosmos since its earliest moment. Close your eyes now and imagine walking in a straight line beneath the stars, step after step, time after time. You never reach an edge, never fall away. The stars may change around you, but the path is endless and whole. In such a universe, every road is home. In the next part, we will drift into the idea of the multiverse, how our cosmos might be just one bubble among countless others, each with its own story, and what that means for the question, what lies on the other side? Picture a vast ocean, not of water, but of possibilities. In this ocean, bubbles appear quietly, randomly, endlessly. Each bubble is a universe with its own space, its own time, its own story. Our cosmos is one such bubble. Somewhere far beyond our horizon, other bubbles drift, expand, and fade from one another's reach. They never touch, they never share light. Yet together, they make a greater whole, a multiverse, a sea of universes. How might such bubbles form? Begin with a simple image, a field of energy like a high plateau stretching in every direction. On that plateau, space swells swiftly, faster than anything inside can keep up. Now and then, a tiny patch relaxes, like a small dimple forming in the plateau. In that patch, the frantic swelling slows to a gentler expansion, and hot, newborn matter appears. That patch becomes a bubble universe. Inside it, stars will one day ignite, and worlds will one day wake. Outside it, the plateau remains, still swelling, still spawning new bubbles. This idea is called eternal inflation, and though we cannot visit the outside, it offers a calm way to picture a multiverse, creation not as a single moment, but as a quiet, ongoing process. In a bubbling cosmos, every bubble may play by slightly different rules. Not wild, chaotic rules, but variations on a theme. Some bubbles make galaxies early, some late. Some grow denser, large-scale webs, others more open voids. A few might be lifeless, too hot, or too sparse for stars to last. A few might be gentle and long-lived, like ours, where chemistry has time to learn how to sing. If you imagine the multiverse as a vast orchard, most fruit falls unripe, some ripens briefly, and a small share becomes sweet and full. We live in one of those sweet places, not because we earned it, but because that is where listeners like us can arise. Can bubbles meet? It is a tempting thought. Two universes brushing edges, leaving a faint ring or scar in the sky. People have searched for such scars in the oldest light we can see, the thin afterglow of the early hot phase. So far, nothing conclusive. The silence does not prove that contacts never happen. It simply tells us that if they do, the traces are too subtle for our present eyes. The ocean keeps its distance, and each bubble drifts in its own hush. There is another kind of multiverse that lives not in space, but in possibility, like a branching forest of outcomes. When a delicate event can go more than one way, nature does not choose a single path. It allows all paths to exist in a larger story. This is the many worlds idea from quantum theory. It is different from bubble universes born from a swelling field, yet both share a soothing theme. Reality may be richer than the part we directly experience. Tonight, you need not sort their details. Let them drift as gentle images, an orchard of bubbles far away, and a forest of possibilities close to every moment. You might ask, if there are so many universes, why are we in one that looks so welcoming? The quiet answer is selection. In a multiverse that allows many setups, we naturally find ourselves in a place where long-lived stars, stable chemistry, and patient time exist, because only in such places can questions be asked and answers be heard. This is not a trick. It is simply the way observation works. Fish describe water because water is where fish can be. What would the multiverse mean for the other side of the universe? It changes the question softly. The other side might not be an edge over there. It might be a different bubble altogether, separated from us by an expanding, unbridgeable outside. No spaceship crosses that outside. No signal survives that journey. Yet the thought that such bubbles exist can still comfort. It says the story of reality is generous, not stingy. It says the calm we feel under our sky is one of many kinds of calm, all part of a greater, wordless whole. Another picture, two thin, flexible sheets, like soap films, floating close together. On one sheet, our universe lives space, time, stars, and life. On the other, another universe. In certain ideas, gravity can seep between sheets, while light and matter cannot. Collisions of sheets could light new fires. This brain world image is just that, an image, but it gives your mind a soft shape to rest on. If the multiverse is an orchestra, our sheet is a single instrument, playing its lines smoothly. Other instruments are nearby but unheard. Together, they make a symphony that only the whole itself can contain. How might we ever learn if the multiverse is real? Slowly, and with patience, we search for clues in patterns of the oldest light, in the way space expands, in the whisper of particles and fields. We test ideas by their quiet predictions. What should be smooth? What should be lumpy? What should be likely or rare? Most nights, the sky answers modestly. It offers consistency, hints, and the invitation to keep refining our questions. Science is a lullaby of careful curiosity. It keeps rhythm with your breath. For rest, here is a gentle meditation. Picture yourself inside a single glowing bubble, its walls not solid, just the soft boundary of what can be known from here. Beyond your bubble, more lights. Other bubbles float in silence. You cannot touch them. You do not need to. Their existence does not lessen your own. It enlarges the room of wonder. Inside your bubble, stars are born and die, worlds form and weather, and minds wake to ask simple, loving questions. You are one of those minds, and your question tonight, what lies on the other side, belongs to the same deep music that makes the bubble swell. If the multiverse is true, it does not make us small. It makes meaning spacious. It tells us that calm can bloom in many places, that beauty is not a one-time accident. It says, the quiet you feel now, listening to these words, is a thread woven into a fabric so wide that no horizon can hold it. And if the multiverse is not how things are, if our universe is the whole, then the whole is still more than enough, and your wonder has not been wasted for a second. Let your shoulders soften, let your jaw unclench. Imagine the sea of universes receding into a comfortable blur, like city lights seen through a misted window. You do not need to count them. You do not need to decide which idea wins. All you need is the slow assurance that reality is generous, and that your place within it is steady and warm. In the next part, we will return from the sea of bubbles to the shape of our own sky, and listen for the subtle hints, echoes, alignments, and gentle fingerprints that could reveal whether space loops, stretches forever, or hides connections too faint to notice, all while keeping our words simple and our pace slow for sleep. Think of the night sky as a quiet page filled with faint handwriting. The universe leaves notes there, soft, precise, and patient. We do not need equations tonight to read them. We only need the idea that light carries memory, and that patterns in that light can tell us about shape, size, and what might lie beyond our horizon. The oldest note is the cosmic microwave background, a thin afterglow from the universe's early hot phase. It is a cool, even bath that fills all directions. On it lie tiny ripples, small, warm, and cool spots. Picture them as gentle freckles on frosted glass. These ripples are frozen sound waves from when the cosmos was dense and buzzing. When space became transparent, the ripples remained, drifting outward ever since. Those ripples act like a ruler. Their typical size on the sky reveals how space is shaped on the largest scales. If space was strongly curved like a sphere or a saddle, the ripples would look stretched or squeezed. What we see instead fits a very flat, very wide geometry. That does not prove the universe is infinite, but it tells us that, within our reach, space is remarkably even, like standing on a calm plane where you cannot feel a global bend beneath your feet. Astronomers also search for echoes of a wrapping universe. If space loops around, light could take more than one route to reach us, creating repeated patterns. One test looks for circles in the sky, matching rings in the afterglow that would show the same patch seen twice. So far, we have not found the clear, repeating rings we would expect. The sky looks original wherever we point, which gently favors a space that is either truly vast or loops on scales larger than we can detect. Another note on the page comes from gravity's lens. Mass bends light. When a massive cluster of galaxies lies between us and something farther away, its gravity acts like glass, stretching and warping the distant light into arcs. By mapping these subtle distortions across wide fields, astronomers can weigh invisible matter, trace the cosmic web, and test how space itself is arranged. The results agree with the flat, wide picture and help track how the expansion has changed with time. Supernovae, the bright, brief deaths of certain stars, add a different clue. Some of these explosions shine with a reliable pattern, making them standard candles. By comparing how bright they appear with how much their light has been stretched by expansion, we can read the universe's recent history. Those measurements revealed that the expansion is gently speeding up, as if a quiet pressure, what we call dark energy, is pushing space apart. That change of pace shapes the horizon and limits which distant places can ever send us light. There is also a soft drumbeat in the positions of galaxies themselves. Long ago, the same sound waves that freckled the afterglow left a preferred spacing in matter, a faint tendency for galaxies to be separated by a certain large distance. This feature, called a baryon acoustic oscillation, is a yardstick we can lay across billions of light years. Measuring it at different times gives another read on both the expansion and the overall shape. Surveys that map millions of galaxies reveal a web, long filaments, dense knots, and vast quiet voids. Up close, the web looks wild. Step back and it smooths into a near uniform mist, exactly the balance a simple cosmos would make as it grows. The way this web changes with distance tells a story that matches the afterglow, lensing, and supernovae. All signs point to a universe that is wide, nearly flat, and today dominated by a gentle energy that accelerates its growth. Still, the page holds a few odd smudges. There is an unusually large, cool patch in one part of the sky, a cold spot that might be a statistical fluke or the shadow of a huge, sparse region of space. Some of the broadest ripples in the afterglow line up more than we would expect by chance. These curiosities are not loud enough to overturn the main picture, but they invite patience and open minds. New instruments promise clearer notes. Space telescopes and wide-field surveys are measuring lensing more precisely, finding more supernovae, and mapping the web in finer detail. They also study the afterglow's faint polarization, the direction in which its light waves wiggle, which carries extra information about the earliest moments. Each improvement tightens the ruler, sharpens the yardstick, and helps us tell whether space is truly flat forever or only appears so within our tiny bubble. What do these clues say about the other side? They do not draw a map. They draw an honest boundary. Within our horizon, the universe is smooth on average, shaped like a wide, calm sheet, and gently speeding up in its expansion. Beyond the horizon, no measurement can yet speak directly, but an even, simple interior hints at an exterior that is not wildly different. More web, more void, more quiet growth. If space loops, it likely does so on scales larger than we can currently test. If it goes on without end, the pattern simply continues beyond sight. There is comfort in the way these separate notes agree. Light from the baby universe, light bent by clusters, light from dying stars, and the spacing of galaxies all hum the same key. When unrelated clues converge, confidence grows. We may not see the other side, but we can feel the logic that carries past our sight, the way a song continues even when the instrument slips behind a wall. Let the sky's quiet handwriting be enough for now. A flat, generous geometry, a patient expansion, and a horizon that is a curtain of time, not a brick line. What lies beyond that curtain remains unwritten on our page, but nothing in the notes we have read suggests a sudden edge. The story flows on. Think of the universe as a stage where the curtains themselves are moving. We do not sit before a fixed backdrop. The backdrop is drifting outward, and our view is limited by two gentle edges that come from time as much as from distance. One edge is about the past, how far light has had time to reach us since the beginning we can trace. The other edge is about the future, how far events can ever touch us if the expansion keeps speeding up. These are called horizons, and they give the other side a deeper meaning than a faraway wall. The first horizon is the past light horizon, sometimes called the observable limit. It is the boundary of messages that have arrived so far. Every galaxy inside it has had enough time to send at least one postcard of light that we can now read. Beyond it, the postcards are still in flight. They are real, they just have not arrived yet. As the universe ages, this horizon grows. More postcards reach our mailbox. That is why new telescopes can keep discovering older and dimmer galaxies. Time's delivery continues. The second horizon is softer but more final, a future event horizon. Because the expansion is gently accelerating, there are regions whose later messages will never reach us, no matter how long we wait. They are slipping away on a widening current. We can see some of them now, because their earlier light left when they were closer. But each year, more of the universe's future slips beyond our ability to hear from it. It is like watching the sun set behind distant hills and knowing that villages you could once see will spend the night beyond sight. This does not break the speed of light. Nothing is racing through space faster than light. Instead, space itself is stretching between places. Imagine two boats anchored in a broad, slow tide. Neither boat moves through the water, but the tide carries them apart. Their separation can grow faster than a swimmer could ever bridge, and yet no one has sped through the water. In the same way, distant galaxies can drift apart faster than light can cross the distance, because the distance itself is growing. These horizons shape the kind of other side we can talk about. The past light horizon says, here is how far we can see. The event horizon says, here is how far can ever affect us. The first is like the radius of a lantern's glow on a foggy night. The second is like the edge of the fog that will never lift, even by morning. Together they draw a circle, not around what exists, but around what can ever share signals with us. Light's color tells this story too. As space stretches, waves of light stretch with it. Their crests drift farther apart, and the color slides toward the red, then beyond red to wavelengths our eyes cannot see. This redshift is not a trick of motion alone, it is the signature of the fabric widening. The most ancient light we detect, the thin afterglow that fills the sky, has been stretched from a fierce brightness to a soft, cold whisper. In the far future, even familiar galaxies will fade toward this whisper as their light is pulled longer and longer. The sky's masterpiece becomes a sepia memory, not gone, but gentled. You can picture all of this with a simple cone of light. Draw time upward, like stacking pages into a book. On each page, draw a circle for the region that can talk to you at that moment. As you flip pages forward, the circles change. Near the beginning, the circle is tiny. With time, it widens as more light arrives. But far into the future, the circle stops growing as quickly. The accelerating expansion keeps pushing distant events outside the cone. The book still adds pages, yet fewer new places can ever join the conversation. What does this mean for exploration? It means that going to the edge is not simply about building a faster ship. Even a perfect craft that skims just under light speed would be bound by the same horizons. You could visit many nearby galaxies, given enough time, but not all, and certainly not the regions already slipping beyond the event horizon. Our limits are not just engineering. They are woven into the geometry of space and the patience of time. And still, these limits are generous. Within our horizon live hundreds of billions of galaxies, each a city of stars with its own weather, its own seasons, its own chemical stories. The part of reality that can ever talk to us is already more than any civilization could map in full. When we ask what lies on the other side, we are not shrinking what we have. We are admitting, with a quiet kind of joy, that reality is larger than the part we can share signals with. The horizons also give a gentle answer to a common question. If there is an edge, what is outside? There is no outside in the way a room has walls and then a hallway. The horizon is not a wall at all. It is the limit of connection. Beyond it, the universe continues, more web, more void, more histories, just not in causal contact with us. If space loops on itself in some grand way, that loop occurs on scales beyond our present tests. If space goes on without end, the pattern simply extends. Either way, the horizon remains a curtain of time, not a fence of matter. Astronomers read these horizons using several instruments at once: the ripples in the ancient afterglow, the bright beacons of distant supernovae, the subtle warping of background light by gravity, and the preferred spacing in the great cosmic web. Each clue is modest by itself. Together, they form a consistent picture of a universe that is wide, nearly flat, and gently accelerating. Projects from space agencies like NASA and ESA add new data points each year, not to close the book, but to make the outline sharper and the possibilities more honest. In the end, horizons do not steal wonder, they focus it. They tell us where knowledge turns into imagination, and they give that boundary a shape we can respect. On this side, we have evidence patient, converging, careful. On the other side, we have possibilities endless, but not lawless. The story continues in both directions. In the next part, we will travel into the deep future and ask what the sky will look like as the expansion rolls on, how stars fade, how the last light lingers, and what other side means when time itself stretches beyond the life of galaxies. Imagine the universe coasting into the far future. The great clusters keep drifting apart as space widens, and familiar constellations loosen like beads on a long thread. Galaxies in our local neighborhood stay bound together, slowly merging into a single island of stars. Beyond that island, more of the cosmos slips out of reach. Star-making is generous at first and then frugal. Early on, Gas clouds collapse often, lighting new suns. With time, easy fuel is spent or locked into faint, long-lived stars. The birth rate slows. Bright blue giants burn quickly and fade, while small red dwarfs sip their fuel for ages. The sky's theater shifts from fireworks to slow candle. Across eons, galaxies soften, many stars die gently, puffing shells of color into space and leaving white embers, white dwarfs hot at first, then cooling for a very long time. Heavier stars end more dramatically, collapsing into neutron stars or black holes. These remnants are the thrift boxes of the cosmos, storing dense memories of stellar lives. The background glow that once blazed as the universe's first light keeps cooling as space stretches. It began as fire, became a faint microwave whisper, and will slide beyond even that wavelengths so long they are more rhythm than color. Reading cosmic history in light alone will grow harder. Acceleration changes the long view. Because space expands faster and faster, distant galaxies we see today will one day be too far for their new light to reach us. The ledger of the visible shrinks, page by page. Eventually, only our local island remains in contact with itself. A future astronomer might look up and think the universe is only this single city of stars. Without old records, they would never know how wide the sea once looked. What becomes of the stars that remain? The big ones go first. Short and brilliant, middleweight suns like ours live steady lives and drift into dim embers. The tiny ones, quiet red dwarfs, linger so long that long feels too small a word. Their light is mild, their pace unhurried. Even they, at last, will run out of fuel. The sky will belong to the afterglow of leftovers, cooling embers, rare flares, and the hush between. Planets have their own fates. Some are swallowed as their stars swell near the end. Some wander loose, nudged by gravitational dances, drifting through interstellar night. Heat becomes a luxury. Energy spreads out, like perfume fading in a vast room. The universe moves toward a state where nothing dramatic happens on its own, because useful contrasts have evened out. People call this heat death, less a death than a quieting an end to easy work, not to existence. Black holes, the anchors left by the largest stars and by galaxy hearts, will rule the late ages. They do not shine, they hold, yet even these anchors may not be eternal. Theory suggests that over unthinkable spans, they can slowly leak energy as a thin, cold radiation. If so, they will shrink grain by grain, their last flickers more whisper than blaze. The final light of the universe may be this faint breath from its darkest objects. In the deepest future, if matter is stable, the cosmos becomes a museum of remnants. Cold white dwarfs turned black, faint neutron stars, and lonely planets coasting through a diluted night. If matter is not stable, even those relics may dissolve. Either way, change grows slow. Time becomes a wide plain with gentle slopes, not cliffs. What does the other side of the universe mean when stars are gone and horizons have closed? It becomes a phrase about memory and reach. The other side is all the places whose messages never arrive and all the histories too faint to track. It is the part of reality that shares no signals with you but still exists, continuing its own quiet processes. In a far future sky, the other side presses in close, not because the universe has shrunk, but because communication has. There is a kind of grace in this outcome. The early cosmos is loud, hot, dense, crowded with new things. The late cosmos is composed cool, sparse, patient. We live in a middle passage where structure is rich and the lights are still bright enough to study. If a civilization hopes to keep its lamps lit, it will learn thrift. It might store energy, harvest the gentle power of long-lived stars, and move slowly, matching the scale of time around it. Travel between islands will grow impractical, then impossible. The wise project will be to tend a single island well, make meaning locally, write clear records, and send messages forward that carry the memory of a wider sky. And yet, the story does not end. It just stretches. Even if the last sparks fade, the fabric remains the geometry, the quiet, the faintest hum of what once was. If black holes truly evaporate, their whisper adds one more stanza to the poem of light. If they do not, the poem becomes a long silence. Both outcomes are conclusions to a movement before time continues into empty measures. When you ask about the other side in this far future frame, the answer is not a distant shore to sail to, but a recognition. The other side is the portion of reality you cannot trade messages with anymore. Today, that lies far away. One day, for future eyes, it will sit just beyond their own island of stars. The universe will still be vast. It will simply be private. In the next part, we will step back from the deep future and ask a practical question for explorers. Given these horizons, what could the grandest journey look like? How far could a patient civilization travel? What tools could stretch its reach? And how does the idea of an edge change when your map is drawn by time as much as by distance? Imagine a civilization that wants to draw the widest possible map not with ink, but with footsteps among the stars. Its explorers know that distance is only half the story. Time is the other half. In a changing universe, the farthest shore you can reach depends on when you depart, how gently you travel, and whether messages can still return. The grandest journey is a conversation with time. Begin small, with a nearby star. The space between stars is wide but not empty. It holds thin gas and faint magnetic fields that thread the galaxy. A careful ship treats that thinness as a gift. It glides and shields itself. It might unfurl a sail to catch starlight, or use magnetic fields to sip energy from charged particles. It aims for gravity assists that bend a path forward without spending much fuel. Now, scale up the ambition. There are gentle ideas for going faster than chemical fire. One is fusion, the same process that powers stars, tamed into steady pulses that push a ship. Another is a beamed sail. A bright, continuous beam from home pushes a thin mirror outward, so the craft leans on light instead of heavy fuel. A third path is a chain of way stations, small habitats around dim, long-lived stars and quiet brown dwarfs, each a lantern to aim for and a workshop to rest in. Travel at a good fraction of light speed brings a quiet bonus. Time on the ship passes a little slower than time back home. The travelers do not feel it. They simply notice that distant milestones arrive sooner by their own clocks than they would for a slower craft. This does not break the speed of light. It comes from the way space and time fit together, making long trips gentler for those aboard. The plan blends speed with softness. You accelerate slowly to protect crew and hull, then coast, then break into a new system. In each system, you look for company. Planets with mild conditions, moons with ice that can become air and water, comets that can become fuel. You build lighthouses, relays that listen and repeat messages so the conversation continues. A network of relays turns a path into a living road. As the network spreads, the map becomes a patchwork of reachable islands. Gravity binds some islands together in families. Our own is the local group. A cluster of galaxies that will remain companions even as the wider universe drifts apart. A patient civilization could visit many of these companion islands over long eras, leapfrogging from star to star and, later, from galaxy to galaxy wherever gravity keeps the doors ajar. The rest of the universe is another matter. Because expansion is gently accelerating, there is a launch window for the farthest destinations. Leave early and move briskly, and some distant galaxies remain within reach. Wait too long, and the widening current carries them beyond any possible contact. The map of reachable space shrinks at the edges, not because the universe contracts, but because connection fades. The other side begins where conversation can never be joined. How do you stretch that window? You start sooner, move faster within safe limits, and build tools that extend your touch. Beamed sails let a home system push tiny probes to remarkable speeds. Fusion engines let heavier craft carry ecosystems and culture. Gravitational lensing can turn stars into natural amplifiers for telescopes and radios, sending whispers across great distances. Even when travel grows hard, signaling can still reach. Seeding helps too. Send hardy, self-building machines ahead to prepare harbors. They mine, print, and plant the basics of life support. Then, wait. When crude ships arrive, they find a welcome air to breathe, water to drink, power to use, shelters to mend. Over time, the seeded lights become an archipelago of safety, each a promise that the road continues. Every map has an honest edge. No chain of way stations can cross a gap that time itself enlarges faster than light can bridge. The event horizon is a practical border as well as a theoretical one. Regions already slipping away cannot be reached by ships, by signals, or by clever tricks that rely on known physics. Hypothetical shortcuts like wormholes or warp drives make lovely stories, but a calm plan stays with what nature has shown to be reliable: patient engines and careful navigation. Respecting limits does not make the journey small. Inside the reachable volume live uncountable suns. A single spiral galaxy holds hundreds of billions of stars, and the local group contains more than one galaxy. Even a modest program that aims for a few nearby systems each century would, over deep time, seed a broad swath of space with life, culture, and listening posts. The map would not be complete, but it would be rich, like a library that grows beyond any one lifetime yet remains legible to its readers. The purpose of the grand journey is not conquest, it is contact and caretaking. Each new system adds diversity, new chemistry, new climates, new puzzles to solve. The travelers become gardeners rather than tourists. They leave places better measured, better understood, and better able to support meaning. They write clear records and store them in long-lived vaults on moons, in deep orbits, around steady red stars, so that memory lasts. Stand back, and the pattern is simple. The grandest journey fills reachable space with gentle lights, habitats, relays, libraries woven into a mesh that endures even as the wider universe recedes. The edge of the map is not a cliff. It is the place where conversation fades. Beyond it, the other side continues, but privately. On this side, the road remains open, and the best tool for walking it is patience. In the next part, we will bring the possibilities together: an endless plain, a looping hall, a sea of bubbles, and a future where the edge is the limit of connection, and compare how each picture fits the notes the sky has given us, using simple language and steady steps. Gather the pictures we have painted so far and set them side by side: an endless plain, a looping hall, a sea of bubbles, and a pair of horizons that frame every view. Each picture answers the same quiet question: what lies on the other side of the universe, with a different shade of meaning. None demands heavy math. All can be felt with simple images and calm language. The aim is not to crown a winner, but to see how each picture fits the notes the sky has already given us. Begin with the endless plain. In this view, space is very nearly flat and may extend without bound. Wherever you go, there is more of the same grand pattern: galaxies woven into a web, voids opening between them, and the slow widening of distance as expansion carries everything apart. Several independent clues hum in harmony with this picture. The oldest afterglow is remarkably smooth on average. The spacing of galaxies carries a faint, standard yardstick across billions of light years. Gravity gently bends background light in ways that match a wide, even geometry. Certain supernovae keep time for us, showing how the expansion has changed. None of these clues alone is decisive, but together they make a melody that favors a vast, nearly flat cosmos where the other side is simply more of the same beyond our sight. Set the looping hole beside it. A finite but unbounded cosmos has no edge and no outside, yet it closes on itself in a clever global shape. Walk straight and, given enough time and distance, you could return to where you began. This picture makes a testable promise: echoes. If light can loop, the same features might appear more than once, matching circles in the ancient afterglow or repeated motifs in the very largest maps of galaxies. People have searched carefully for those repetitions. So far, the sky appears original in every direction. That does not slay the idea. It only says that if space loops, it likely does so on scales larger than we can currently test. In this picture, the other side is not a cliff, but another path that eventually leads home. Now place the sea of bubbles on the table. In eternal inflation stories, a high-energy field spawns pocket universes the way deep water throws off foam. Each pocket cools and expands with its own local details set by how it fell from the high plateau. Our visible cosmos would be one such pocket. Between pockets lies a region no signal can cross, so this is not an outside anyone can sail through. The hints here are statistical rather than direct. Very slight fingerprints in ancient light, distributions of certain features, or rare patterns that might favor a bubbling origin. Nothing conclusive has appeared yet. The multiverse remains a possibility, not a settled fact. In this picture, the other side could be another pocket entirely forever separate, yet part of a larger whole. Finally, frame all pictures with horizons. One horizon is about the past, how far light has had time to reach us. The other is about the future, how far events can ever touch us. If the expansion keeps speeding up, these horizons are not walls, they are limits of conversation. Even in an endless plane, we only hear from a circle of it. Even in a looping hall, we can test only a small arc. Even in a sea of bubbles, we live within one pocket whose shoreline cannot be crossed by light. Horizons remind us that every answer must respect time's patience. Now, compare the promises. The endless plane promises consistency. The farther you look, the more the average view stays the same. The looping hall promises echoes, repeated patterns, or alignments that stand out from chance. The sea of bubbles promises variety we cannot visit, but might infer in delicate statistics. Horizons promise a moving boundary, a past we will keep reading more deeply as light arrives, and a future we will gradually lose to silence as expansion gains ground. What do the notes of the sky favor today? They favor the plane while leaving room for a loop too vast to test. They keep the sea of bubbles in play, neither confirmed nor dismissed. And they anchor the horizons as real features of our situation, because we directly measure a universe that is expanding and gently accelerating. That combination, wide, nearly flat, and accelerating, draws the most conservative line through the evidence without closing the door on deeper geometry. Notice the shared thread. None of the pictures places a material wall at the edge of being. In every case, the other side is not a cliff beyond which nothing exists. It is either more of the same pattern beyond sight, or a return path folded into a larger shape, or another pocket in a broader sea, or a region that can never trade messages with us. The edge that matters is the edge of connection. This has a quiet consequence for meaning. If there is no hard boundary, we do not live at a brink. We live inside a story that continues past our page. Our part is already immense. Hundreds of billions of galaxies inside our communication horizon, each a city of stars with its own seasons and chemistry. Asking about the other side does not shrink what we have. It enlarges our sense of home and turns our measurements into conversations with a greater whole. How should curiosity proceed? With patience and humility. Patience gathers more light, deeper maps of the cosmic web, sharper measures of ancient ripples, cleaner readings of faint lensing, steadier catalogues of supernovae. Humility keeps us honest about what a measurement can and cannot decide. It lets us say, likely and still possible, instead of forcing certainty where the sky has not granted it. When separate clues agree, confidence rises. When they disagree, the mismatch becomes a lantern pointing to better questions and better instruments. These pictures also differ in how they guide imagination. The endless plane invites openness. Wherever you look, there is more to learn. The looping hall invites completeness. Every path leads back into the same hole. The sea of bubbles invites generosity. Reality may support many stories at once. The horizons invite respect for limits. Even a generous reality does not promise contact with all of itself. Hold them together, and a single calm insight emerges. Whatever lies on the other side of what we can see is not an absence but a continuation of pattern, of possibility, of time. In the next part, we will turn from grand geometry to a single traveler, a beam of ancient light. We will follow it from its hot birth through a widening space to our instruments today and show, step by step, how it carries the universe's memory without leaning on heavy math. Picture a single messenger of light, a photon carrying three simple facts: its color, its direction, and the way its electric field wiggles, its polarization. The suitcase is small, yet inside it sits a record of the universe's road. Our photon begins when the cosmos cools from a blinding fog into a clear sky. For a few 100,000 years after the hot beginning, space was a bright soup that scattered light so quickly nothing could travel far. Then the soup thinned, atoms formed, and the fog cleared. Light decoupled from matter and finally ran free. That ancient light is the afterglow we still detect, the cosmic microwave background. From its first moment of freedom, expansion goes to work on the photon's color. As space stretches, the distance between wave crests stretches too, sliding the color toward red. It is like a bell that, as the room expands, rings in a deeper tone. The photon's tone becomes a clock. The redder it is when it arrives, the longer it has been traveling, and the more the cosmos has swelled. The path is not perfectly straight. Gravity dimples space wherever mass gathers around galaxies, clusters, and great rivers of unseen matter. Passing these dimples, the photon's route bends a little, like a stream curving around stones. This gentle deflection, gravitational lensing, does not steal the photon. It redirects it, subtly warping the view of whatever lies beyond. The photon also drifts through thin fogs, clouds of gas between galaxies. Most are barely there, but each can steal a sliver of color. Stack many such photons, and a delicate barcode appears, a record of where those fogs were and how the universe changed with distance. From birth, polarization carries a whisper of the early cosmos. When light last scattered off free electrons in that young sky, it picked up a preferred wiggle. Patterns in those wiggles, mapped across the dome, tell us about ripples that rang through the baby universe, the seeds of galaxies, and may one day reveal subtler swirls linked to violent processes near the beginning. Now switch to a younger photon, one born in the heart of a distant star or in the bright core of a young galaxy. It carries a more recent story, but the same rules guide its trip. Expansion reddens it, gravity bends it, thin fogs notch its spectrum. If two paths around a massive cluster bring the photon to us by different routes, it can arrive in duplicate an Einstein mirage, letting us time the delay between the images and weigh the cluster from the difference. Together, ancient and young photons let us build a 3D map from 2D images. Nearby light shows late chapters. Faint, red-shifted light shows earlier chapters. The oldest afterglow shows the prologue. Layer the chapters by color, and you get cosmic tomography slices of the universe at different times, like tree rings read by light instead of wood. Every photon also teaches perspective. When we see a galaxy 10 billion light-years away, we are not seeing it over there right now. We are seeing it as it was 10 billion years ago. The more distant the source, the deeper into the past our view reaches. There is no live broadcast from the far side of the cosmos, only an archive that thins with distance. Past a certain remove, there is no archive at all yet. The first messages are still en route. Because expansion is gently accelerating, there is a horizon in the future as well as in the past. Some places we can see today sent their light long ago when they were nearer. Their new light, starting now, will never catch us. Photons launched this minute from those regions are like runners on a track that stretches under their feet. They run forever and never close the gap. The universe allows journeys, but not all journeys can be completed. Even within those limits, a single photon's baggage is rich. Color tells distance and time. Polarization tells early motion. Direction tells geometry. Put millions together, and patterns leap out ripples in the afterglow. yardsticks in galaxy spacing, and shear fields from lensing. Independent clues cross-check each other until a consistent landscape emerges. Wide, nearly flat space, slow growth that has begun to accelerate, structures raised from tiny seeds amplified over time. Think how little the photon asks of us. We do not chase it. We listen well when it arrives, keep detectors cold and quiet, clean away local noise, and compare results from instruments that do not share the same errors. The discipline is simple: gather, calibrate, cross-test. The reward is a view that reaches across nearly all of time available to sight. What does our traveler say about the other side? It says there is always more message than we have received. The sky we see is a shell, the set of places whose light has reached us by now. Outside that shell, the story continues, unwitnessed so far. The shell grows as time passes, but accelerating expansion ensures that some volumes will forever stay beyond correspondence. Light arrives carrying both the richness of what it crossed and the confession of what it could not. In the end, the map we build from photons is not a picture of everything, but it is a faithful portrait of our accessible part. It shows no hard wall at the boundary, only a gentle fade of information with distance and time. Beyond that fade, the universe remains more web, more void, more histories unfolding. Our photon has threaded one path through that larger fabric and handed us a strand. With enough strands, woven carefully, a pattern appears. It is not all of reality, but it is real enough to guide us. In the next part, we will turn from messengers to makers. What sets the scale of the cosmic web? Why galaxies line up in filaments and sheets? And how those shapes hint at what the rest of the universe may look like beyond our field of view. Picture the universe from far above, as if the night could be peeled back to show its bones. You would see a pattern like lace or river deltas, long filaments crossing in bright knots, with wide, quiet spaces between. This is the cosmic web, the large-scale structure built by gravity. What makes the web? Begin with the early universe, which was smooth but not perfect. Tiny ripples in density, some regions a hair heavier, some a hair lighter, gave gravity a head start. Heavier spots pulled a little more matter, which made them heavier still. Over time, small bumps grew into clouds, clouds stretched into strands, strands fed the junctions we call galaxy clusters. The thin areas became great voids. Much of the framework is invisible. We call it dark matter not because it is sinister, but because it neither glows nor reflects. It feels gravity and provides the scaffolding on which ordinary matter, gas, stars, planets collects. Think of dark matter as the quiet trellis. The things we see are the vines climbing it. Where the trellis is thick, galaxies gather. Where it is sparse, space stays open. The web's shapes, sheets, filaments, and knots arise because matter rarely collapses evenly. If gravity squeezes a region more along one direction than another, it first forms a thin pancake. Continued pull along a second direction turns parts of that sheet into lines, filaments. Where several filaments meet, a knot forms, a cluster heavy enough to bend light from more distant objects into arcs. Step by step, gentle ripples become an intricate network. There is also a faint rhythm set before space turned transparent. In that hot, early era, pressure and gravity made sound waves that rolled through the mix of matter and light. When the fog cleared and light ran free, those waves left a preferred spacing in the distribution of matter. Subtle on its own, across huge distances it becomes a ruler we can lay over galaxy maps. The same physics that freckled the ancient afterglow set this yardstick in the web. Gas follows the dark frame and then cools, collapses, and kindles stars. Supernovae stir and enrich it. Black holes in galaxy centers switch on, launching winds and jets that shape their neighborhoods. Each galaxy is its own weather system inside the broader climate of the web. Local details can be wild mergers, bursts of star-making, but the global pattern is calm and repetitive, strands feeding knots, voids widening around them. How do we know the web is real? We trace it in independent ways. We count galaxies across wide areas and sort them by how much expansion has stretched their light. We map how gravity subtly distorts the shapes of background galaxies, weak lensing to infer where mass lies. We study hot gas in clusters, which glows in high-energy light and scatters the ancient afterglow. Each method draws the same network with a different pen. Computer experiments help too. Give a simulation, simple ingredients, initial ripples, gravity, expansion, dark matter, and let it run. A web blooms that looks strikingly like what we observe. Add gas physics and star formation, and the match grows closer. Simulations are not proof, but they show that small seeds and long patience naturally lead to the structures we see. Voids are as important as filaments, with little mass to slow things down. Local expansion inside a void runs a touch ahead. Matter gently drains toward the surrounding walls and threads, so voids grow emptier and larger over time. They are clean windows into the rules of space. What does the web tell us about the other side of the universe? It hints at continuity. The same rules that sculpt structure here, gravity, expansion, and the quiet guidance of dark matter should sculpt it elsewhere unless the laws themselves change. Because separate clues agree, the afterglow's ripples, the web's yardstick, lensing maps, cluster gas, the natural guess is that the pattern extends, more filaments feeding more knots, more voids opening like lakes between them, far beyond our horizon. This does not mean every region looks the same. The web is a pattern with variation, like weather on a planet. Some neighborhoods are rich in clusters, others are broad, calm voids. Over very large scales, the mix averages out. That averaging cosmic homogeneity does not erase local drama. It simply says the drama comes from the same rulebook everywhere we can test. The web also clarifies what our horizon island. It is not the end of the lattice, it is the limit of what we can light with information. Picture holding a lantern in a vast cave full of arches. The arches do not end where your light fades. They carry on. As your lantern burns longer and you turn to new angles, more arches come into view, and their shapes match the ones you already saw. The cave's design reveals itself by echo rather than by exposing every corner at once. In practice, deeper surveys that reach farther back in time keep finding the same architecture in a younger form, thinner threads, smaller knots, gas just learning the rhythm that will later build galaxies. If one day we uncovered sharp departures, mismatches too strong to be chance, that would hint at new physics or a change in the rules beyond our present page. For now, the web reads like a sentence that continues smoothly off the edge of our paper. The cosmic web leads to a humble conclusion. The other side of the universe is likely not a different kind of place, but a farther stretch of the same grand weave. The details vary. The loom is shared. Our maps will never cover it all, yet the portion we can chart is enough to guess the style of what we cannot. In the next part, we will smooth out common confusions, where the center would be, whether space is expanding into something, and why asking for an outside to the universe is like asking for a point north of the North Pole. Easy to say, but not a useful question. Imagine standing in an open field and asking, where is the center of this sky? You turn in every direction and the dome looks the same. That is how the universe behaves at the largest scales. There is no marked center to travel toward, and no edge to fall off. Every place is the center of its own observable bubble. The Big Bang did not burst from a point in pre-existing space. It happened everywhere at once, because space itself was hot and dense everywhere. A vivid but misleading picture imagines a firework racing outward into emptiness. It sneaks in a mistake, an outside. The expansion we measure is not motion through space into a surrounding void. It is the growth of distances defined by space itself. You do not need a bigger room for the room to feel bigger if the floorboards stretch. In cosmology, the floorboards are the metric, the ruler that turns coordinates into distances, and that ruler changes with time. Think of raisins in rising dough. As the dough puffs up, every raisin sees the others drift away. No raisin sits at the center. The center is the baking that fills the loaf. If you lived on a raisin and asked, "What is the bread expanding into?" the useful answer inside the loaf would be, "There is more bread between raisins." Likewise, we do not need an outside for space to grow. Asking what the universe expands into is like asking what a number line sits inside. The question assumes a container that isn't part of the description. Another confusion. If some far galaxies recede faster than light, doesn't that break the speed limit? It doesn't, because nothing is shooting through local space faster than light. The space between distant points grows. Picture two ants on a stretching rubber band. The ants never crawl faster than their rule allows, yet the marks between them spread faster than either ant can cover. Locally, the ants obey the speed limit. Globally, the changing band carries them apart. People also ask where the Big Bang happened. The best answer is simple: here and everywhere else. Take any galaxy and run the cosmic clock backward. The matter now in that galaxy was once in a smaller, hotter state along with everything else. The beginning describes a time, not a location. We live in the aftermath throughout space. What about an outside to the whole? If space is everything that can be labeled with coordinates every here that could hold a ruler, then asking for an outside is asking for a place that is not a place. It's like asking for a point north of the North Pole. You can say the words, but they do not select a meaningful destination. If space is finite and unbounded, you can travel forever without meeting an edge. If space is infinite, edges are even less useful. Either way, outside is not part of the map. Does the balloon analogy imply a true center in some higher dimension? Remember the point of the analogy. The balloon's two-dimensional surface stands in for all of space. Creatures restricted to that surface would measure distances along it and find everything sliding away as the surface grows. From their point of view, there is no center on the surface and no edge. The center you picture in the balloon's volume belongs to the analogy, not to their world. If the universe is the same everywhere on large scales, why is our patch so lumpy? Because that statement is about averages across great distances, not about local neighborhoods. Up close, gravity builds structure, stars, galaxies, clusters, voids. Step back far enough, and the bumps blur into smoothness, the way mountain ranges become a faint haze when seen from orbit. Then there's the phrase, edge of the observable universe. Is it a hard wall? No. It is a horizon made of time, the limit of light that has arrived since the beginning we can trace. New light from just beyond that radius is still on the way, so the observable region grows as time passes. Because expansion is currently speeding up, there is also a future event horizon that marks what can ever send us new signals. This is not a wall either. It is a limit on future contact. You may hear claims that a true center exists because of odd alignments or cold spots in the ancient afterglow. Small anomalies do appear, and scientists test them carefully. But the overall weight of evidence points to no special position for us. Our place is ordinary in the large-scale sense, which is quietly beautiful. It means the laws we learn here likely hold far away, and the questions we ask are not uniquely local. Summing up the clean answers to common confusions, the universe has no center in space. The Big Bang was an event in time, everywhere. Space is not expanding into an outside. The metric that measures distances is changing. Superluminal recession does not break the speed limit. It reflects the growth of space itself. The edge we mention is a horizon of communication, not a wall, and the outside is not part of our map because space already is the map. Clear these knots away and the picture is simple and calm. We live in a wide, nearly flat cosmos that grows with time, builds a graceful web from small seeds, and presents us with horizons where knowledge yields to imagination. What lies on the other side of the universe is not a brick boundary, but a continuation more pattern beyond our page. In the next part, we will return to human scale and feeling, why the question of the other side matters to us, how wonder can be a steady companion, and how a clear view of limits can make meaning larger rather than smaller. Meaning grows in the space between a question and its answer. What lies on the other side of the universe? is one of those questions that never fully closes, and that is part of its gift. It gives the mind room to wander without getting lost. It invites humility, because no person, no instrument, and no error owns the final word. And it offers companionship, because people across centuries have looked up and asked the same thing under the same quiet dome. Why does this matter to daily life? Because it changes scale without changing care. The same attention you give to a friend's voice or to a quiet street at dusk is the attention you can give to the sky. Wonder is not a luxury, it is a way of paying respect. When you ask about the horizon, you practice listening to something bigger than yourself without demanding that it shrink to fit you. That practice widens the room inside. Limits help rather than harm this feeling. A horizon is not a failure. It is a shape that allows meaning to form. If every answer were obvious, curiosity would have nowhere to go. Because there are places we cannot reach and messages we cannot receive, imagination earns a job. It becomes a careful partner to evidence, not a replacement for it. Evidence draws the line. Imagination colors to the edge. Clarity calms as well. Many restless thoughts come from mixed pictures, half myth, half guess, half memory of a movie. The clean idea that the universe has no center, that expansion is distance growing rather than things racing into a void, and that the edge is a limit of connection rather than a wall. These frames turn noisy puzzles into quiet shapes you can hold without strain. A clear picture frees attention and makes room to breathe. The question reminds you that we live in the middle, not only between the very small and the very large, but between deep past and deep future. Our species woke after the first stars had already burned, and before the last embers have cooled. We stand in a bright corridor of time where there is enough structure to study and enough light to see by. That corridor will not last forever, but it is wide enough for meaning, and we are lucky to walk it. Meaning does not require mastery. It asks for participation. You participate by noticing. You notice how seasons shift the constellations. You notice how moonlight changes the color of familiar streets. You notice a new image of a distant galaxy, and remember that you are seeing it as it was, not as it is now. Each small noticing ties you more closely to the quiet rules we have been exploring. The other side of the universe, in a human sense, is also the other side of our habits, the side where utility yields to awe, where efficiency pauses for reflection. You do not need to abandon your plans to step there. You only need to add a pause between task and task, long enough to let a larger pattern pass through you. Questions that cannot be finished are perfect for these pauses, because they do not demand an action item, they offer orientation. There is a social thread here too. Shared wonder is a bridge. When two people look up and say, "I don't know what lies beyond," they have already agreed on something deep, that reality is larger than either of them, and that listening together is worthwhile. That agreement makes better conversations about everything else. It teaches a style of disagreement that can still be kind, because both sides remember they are small under the same sky. Science joins this circle not as a stern judge, but as a disciplined listener. It keeps notes, builds instruments, and discards ideas that fail their own tests. This discipline is a form of respect, the same respect you would show someone you love, by listening to what they actually say rather than to what you hope they will say. In return, the universe has been generous, giving us a steady melody, wide space, patient growth, gentle acceleration, and a web raised from tiny seeds. When the melody meets mystery in odd alignment, a cold patch, a sudden change of pace, discipline does not vanish. It becomes curiosity with manners. We ask better questions, check for errors, and design cleaner tests. Sometimes the anomaly fades under better light. Sometimes it hardens into a new truth. Either way, the process adds calm rather than noise. All of this remains compatible with rest. The cosmos does not ask you to be an expert to belong here. Belonging is automatic. You are made of its old stars and moved by its quiet rhythms. If you want a small practice that links feeling to fact, pick a bright star and think of it as a place, sunlight, planets perhaps, gravity, weather. Then, without strain, remember that a single galaxy holds countless such places, and that galaxies themselves are many beyond easy numbering. The mind stretches, and the world you already inhabit feels larger without changing its address. The question of the other side is also a question of stewardship and gratitude. Knowing that horizons limit contact makes the nearby more precious. If our island of stars is one day the only sky future eyes can study, then our records, relays, and archives matter. Our care for what we can touch, our air, our water, our cultures matters, because these are the pages of the story we can actually edit. Meanwhile, gratitude grows, the moving planets, the path of our galaxy on a clear night, the careful images returned by observatories, the simple relations that, despite their symbols, say something honest about how distance, time, and light fit together. You do not need to see everything to be grateful. You only need to see that more exists than any one life can hold. So what does it add up to? A gentle posture. You stand in a wide place. You know there are horizons, and you ask big questions without hurry. You respect evidence because it steadies imagination, and you keep imagination because it gives evidence a home. You care for the part of the universe you can touch, your street, your people, your work, while leaving room in your mind for oceans you will never sail. That is not shrinking your life. It is folding it into a larger field where knowledge and mystery can share the same roof. In the next part, we will close our journey by returning to the horizon itself and giving a simple, honest answer to the title's question, one that holds what we have learned, that the other side is not a wall, but a continuation, not a void, but more story, and that knowing this can make the night feel both vast and kind. What lies on the other side of the universe? The most honest answer is simple and calm: more universe. Beyond the farthest light we have received, the pattern continues: galaxies and voids, filaments and clusters, histories unfolding in places whose messages have not yet arrived and, in some cases, never will. The edge we speak of is not a wall of matter, but a horizon of connection, drawn by time and by the steady widening of space. Past that horizon, reality goes on. Everything we have learned points this way. The oldest afterglow is smooth on average, as if space were a wide, even plane. The web of galaxies follows gentle rules, building threads and knots from small seeds under gravity's quiet hand. Light from distant beacons arrives redder than it left, stretched by expansion. Independent clues, the spacing imprinted by ancient sound waves, the bending of background light by mass, and the steady timings of bright stellar explosions agree on a picture that needs no hard boundary at the edge of sight. Still, the mind asks for shape. Offer it two fair pictures and let them rest. In one, the universe is an endless plane. The other side is just farther on. In the other, the universe is finite, yet unbounded. The other side is another path that, with enough distance, leads back to here. There is also a generous third idea. Our visible bubble may be one of many, each a separate room in a larger estate we cannot traverse. None of these pictures puts us at a privileged center. All make our horizon a curtain of time, not a fence of matter. If this answer sounds modest, that is a strength, not a weakness. It leaves space for evidence to speak and for imagination to breathe. It keeps wonder intact while staying faithful to what the sky has shown. In practice, the difference between infinite and immense beyond reach does not change the care we owe to our small piece. Our responsibilities unfold locally, even as meaning stretches to the largest scales we can name. The horizon also teaches kindness toward ignorance. Not all unknowns are problems to be solved. Some are conditions to live under wisely. A sailor does not blame the sea for the fog. They trim the sails, keep the log, and move by the instruments they trust. We do the same. We keep building better detectors, calibrating more carefully, and cross-checking ideas that are beautiful against results that are stubborn. The process is slow and human, but it works, and it lets us say what we know without pretending to know more than we do. So here is a clear, single-sentence answer. carried on all we have gathered. The other side of the universe is a continuation of the same cosmic fabric, more structure, shaped by the same quiet rules lying beyond the region that can ever send us light. That is it. No abyss, no enclosing shell, no outside hallway to step into, just more reality than we can exchange signals with. From that answer flow a few gentle consequences. Meaning is not threatened by scale. Home does not shrink because the world is large. The atoms in your body, made in old stars, connect you to the pattern you cannot see. You belong without needing to witness the whole. Stewardship grows out of that belonging. If future eyes will one day see only our merged local island of stars, then the records we keep, the instruments we protect, and the lessons we pass forward are part of how the universe remembers itself. The question in our title does something else that is quietly practical. It slows us down. When you ask what lies beyond any horizon, you admit that hurry will not help. You trade anxiety for attention. You start to notice how evidence and imagination can share a room without fighting for the chair. That habit, calm curiosity, is useful far beyond astronomy. It steadies conversations, tempers decisions, and leaves space for other minds to breathe. If the day comes when a new clue shifts the picture, an unmistakable echo of a looping space, a statistical fingerprint of neighboring bubbles, or a change in the rhythm of expansion, we will widen the answer with the same care we used to frame this one. That willingness to update is part of the respect we owe the sky. The story is not unfinished because we have failed. It is unfinished because it is still being told. So what lies on the other side of the universe? More story, more time, of the same patient rules, shaping new arrangements we may never meet. The observable edge is where our messages stop crossing, not where existence stops. Between here and there stretches a fabric that has made galaxies, stars, worlds, and listeners. You are one of those listeners. Your question is a thread in the same weave. Let that be enough, and still leave room for wonder. The night above you is not an end cap, but an invitation. The far edge of sight is a promise that there is more to learn and more to imagine, kept honest by what the light has already said. On one side of the horizon, we have evidence. On the other, possibility. Between them runs the path we walk, attentive, humble, and alive to the scale of things. This is where our journey closes, not with a door, but with an open view. The other side is not away from us, it is ahead of us, beyond the reach of any lantern we can lift today. And that is all right. We know the way the path curves, and we know how to keep walking. The sky remains wide, the questions remain good, and the absence of a wall is, itself, a kind of home.